In this video clip, we want to talk about a psychological a tool called standard deviation, also known as the bell curve. You may be familiar with this, but if not, let me show you this because it has a really serious application for a lot of different types of research, especially in psychology. First of all, standard deviation is also called the bell curve. Now, where does it get that name? It's because when we look at this curved line, okay, the old bells, okay, every school used to have a bell, okay, and the old bell, okay, had this and had a big gonger here, had a big clanger, okay, and then that clanger would go back and forth, and that's how it actually gets its name, the bell curve. So, because it simulates the look of the old school bells here. So that's kind of interesting. So you may wonder how in the world it got the name bell curve, but it's because it has that similar structure. Now, we have to realize that what we're talking about in standard deviation is when we draw a line right down the middle, okay, this is the mean, okay? This is the mean or the average. We have to understand that what standard deviation is it's a comparison to the average. It's a comparison to the average. So the line down the middle is the mean. That's the average. So in that case, okay, 50% of the population is going to be that way, and 50% of the population is going to be this way. 50% to the right, 50% to the left. Now, this is kind of an interesting tool because the mean might be really bad, okay? So we might be working with a particular state, and we may want to look at math scores on our standardized test. Well, if the math score, if the mean, let's say the state really maybe is not doing all that good, and you know, 70 is a C. Well, let's say the mean is a 60%. Well, that's not a very good average, okay? But on standard deviation, it doesn't tell us that the mean is 50 or the mean is 70 or the mean is a particular deal. The mean is whatever it is. Oh, so this is the interesting part about standard deviation. Okay, so let's say that the state's really strong in math, okay, and let's say that the mean was 80%. Oh, wow. So now the mean, in order to just get a mean score, just means you were on the average. So we have to be careful in psychology. We say somebody is right on the mean. It's the average. Well, the average could be really good or the average could be really bad. So what we do is we divide up this bell curve, okay? So we put all right, so we have lines on each side. We have 3 lines on each side. Now, there are other variations of the bell curve that can divide it up into even more lines. Okay? So now what we have is we want to know how many standard deviations, how many lines you are from the mean. So this is the mean, okay? So plus 1. Oh, we're plus 1 line from the mean. That means our standard deviation score is a plus 1. Oh. Or in this case, it would be a plus 2, or in this case, it would be a plus 3, or in this case, it would be a plus 4. Oh, okay. So now we're just saying how far we are from the mean. Now, there's different ways to read this, and we'll talk a little bit more when we talk about the analytical section. But once again, this is the general structure of the idea behind standard deviation. So then, here we are. We're minus 1 from the mean, minus 2, minus 3, and minus 4. Okay? So what we're actually saying is, and we used to get these test scores back, and we would say this student has a standard deviation score of a plus 3. Oh, so the student goes, oh, well, that's not a deviation score plus 3. Oh, 3 doesn't sound very high. No, that's pretty good. That means we're 3 lines beyond the standard deviation. Okay? So the standard deviation score of 0, you're like, oh, I didn't do very good at all. Well, that's the mean. Okay, so standard deviation is different from the mean. So let's talk about intelligence. Okay, let's talk about intelligence. Your chronological age, all right, divided by your critical thinking age. Okay, so once again, we look at this and we say where is somebody's IQ? All right, where's somebody's IQ? So it's your actual age minus your processing, or divided by your processing age. So the average IQ should be your chronological, should be your age, okay, over your thinking, okay, times 100. So if your age matches where your thinking should be, then average IQ should equal 100, okay? Average IQ should be 100. So basically, we're hoping that, or we're thinking that, that's going to be a score of 100 IQ. That's going to be about the mean. But it may not be on standard deviation because we may have an area, like for example in this class, where everybody has to test into the class. It's possible that the mean might be, everybody in here might have 110 IQ, and the mean may be 110. So we have to realize that the mean is just the average of whatever sample group we're talking about. But if this is the IQ, okay, then we're going to find this, okay, then we're going to find that way over here in this little bitty section. Okay, now let's talk about this umbrella here represents out of the mass population of people, how many people fit into this curve. Oh, so now when we look, okay, most of the people are going to fit into this. This is the most surface area inside of the bell. Okay, so really small areas. As a matter of fact, we say about 2%. If you have a good cross section, then this is going to be about 2% of the population. And so over here it's going to be about 2%. So if we were to do IQ for the entire United States, or maybe even the whole world, we're going to find that the bell curve is pretty accurate for the most part, because wherever the mean is, whatever it is for the world, whatever it is, about 2% are going to come over here in this +4. So in IQ-wise, these are going to be your extremely gifted genius people. Okay? And then, but you're going to have the same thing. You're going to come back over here. If we do the whole wide world, whatever the mean is, the mean may be 100, it may be 95, it may be 105. But we're going to have about 2% over here, and this is going to be your IQ of below 55, really low functioning IQ. So no matter what you have, you've got 2% on either side. Now, as a high school principal, I used to really get a kick out of teachers who would be like, I would go in and they might be a great teacher, but they might not be a very good teacher. And they might say, well, you know, I don't know why you're thinking I'm not doing a good job in a classroom, because Johnny over here made 100 on the test. You know, and he made 100, and so I must be a good teacher. Well, I hate to inform you, Mr. Not-So-Good Teacher, okay, that no matter what you do, there's going to be, if you've got a good cross-section of people in there, there's always going to be somebody over here that's going to do this, even if they don't listen to a word you say. Wow, so that's interesting. So that's not the question. The question's not, what does this 2% do on either side? The question is, what happens to this area? What happens in this area in the middle that represents 70% of the total population, maybe even 75 or 80, depending on where the mean is. So this is what we're looking at. So when we say in terms of standard deviations, we say this particular person, it falls under this in terms of whether it's IQ or a specific psychological situation. We say somebody with schizophrenia has a certain whatever chance to show a certain trait. So when we say standard deviations, the scores, if it's a +1, 2, 3, 4, that means it's just a comparison to the mean. So we take a look at the mean, we want to see how far over that is. Okay, so it's kind of interesting. We'll talk about it a little bit more as we go. Once again, it's called a bell curve because it resembles a bell. But the reason it's a shape is because the area that's represented by the surface area in each one of these shows the percentage of people that are in there. So when we look at this, the whole thing is 100% of the population, and the population can be defined as large or as small as we want. We can do just the standard deviation of the students in this class, or like I said, we can do the United States or China or Russia or whatever country, or we can do the world. So with this represents the population that fills the surface area in each one of these, and that's a percent. So once again, we say standard deviations. It's standard deviations from the mean. So strictly a comparison to the average. So once again, it depends on what the average is. So just in a quick little look at standard deviation, we want to just once again remind you that it's a comparison to the mean. So hopefully you understand a little bit about standard deviation. We'll talk more about it later, but this is just a quick synopsis of standard deviation.